All right. Before I start this video, I had to put a little disclaimer in my comments. So in this, I keep making a reference. I keep saying this one thing incorrectly. So let me just show you what I am talking about just quickly. And here's the answer. I was saying things uh, like on this one, I was saying. D comes from E and C. Okay, I was saying D comes from E and C. And I was thinking the opposite, but I was saying it incorrectly. So C and E go into D, okay? C and E go into D, not D doesn't come from C. D has C and E feed into it is really what I meant to say. So just a clarifier. So again, I was saying it wrong, and when you watch some more of this video, you'll see that I'm saying it wrong. But I just want to clarify it before we get started. All right. All right, RegNet, or not RegNet, Zoom kicked me out, so hopefully I'm starting this one fresh. So in this particular segment, we're going to work through some network diagram examples. Just so you know, this hat is to let me know when I look at my videos that this is the one that has to do with doing network diagram examples, but that's really for my benefit. Behind me is Uluru. This interesting, maybe an interesting story, but a story anyway, is a couple winters ago when it was so bitterly cold. That one winter was so bitterly cold around Christmas time, you know, like wind chill was like -40, -50 below. We were here at Uluru in Australia, and it was actually 108 that day. So kind of a really huge contrast, you know, it was like 150 to 140 degree temperature difference between the two places. So cool place to go. Don't spend very long there because there's not much to do. All right, so I'm going to go and do the network diagrams. If I haven't told you already, there is a, because I've said it in other videos that I've had to chop off, but there is these examples are in the network and the resource section of RegNet. So in the resource section, under network diagram problems or some sort of folder that's along those lines. So please, before you start following along in this video, please try to work out the problems that you have on your own and then refer to this for perhaps some assistance. I think it's going to make it's going to stick with you better than just following along and working out the problems as you go, because you say, yeah, I got that. And then you may not actually have it. So there's going to be, by the way, there's going to be 4 over the next 4 weeks, I believe 4 over the next 4 weeks. All right, so here we go. Let's jump over here and let's see where we're at. All right. And I'm not looking at the answers, trying to make it a little bit more exciting for all of us. So network diagram practice 01. So that's what yours will say when you actually go to find the right one. So network diagram practice 01. There's the file name right there, just in case you need to know that. All right, so it says record the ES, EFs, and I call these the E's, the L's. Oops, that should have been LF. Huh, all that time we never noticed that. On the network above diagram, and that would be what you'd get points deducted for. Also identify the critical path, again, deduct 2 points. So we're just going to do this. This is kind of the general way of doing it. We've done this before in chapter 14. I say I can start this one at 0 right now. It takes me 2. I get to 2. I go down here. I can start this one at 0. It takes me 1 day or 1 hour. Or we'll say what day for these. 1. And then, remember I told you before we started, we should go identify which ones we have to make E decisions and which ones we have to make L decisions. Whenever we have 2 arrows going into something, we have to make an E. We have to decide between more than one E, decide between these 2 E's, decide between these 2 E's. I'm putting E question mark. And so we went through that way. I think I've captured most of them, all of them. And then we look for things where 2 arrows back into it, and then we have to make an L decision. This was a little bit tricky, but this one is an L because this one backs into it, this one backs into it. So we have to make an L decision. And I should make my L just a hair bit over further because I got to put the numbers in there. Just for sanity's sake. These 2 back into it, I have to make an L decision. That one's okay. That one's okay. I think, I think that looks okay. So let's go ahead and get started. Some further started, I guess. So 0, 2, 0, 1. Here's my decision for this one. I say I have 2 coming out of here. I have 1 coming out of here. For the ease, remember you choose the bigger because L's have small, 2 L's in them, smaller, okay? So the L is the smaller because it has 2 L's in it. So I choose the bigger. I choose 2 over 1 because they both feed into this. 2 plus 4 is 6. Okay, I jump over to this one. I don't have to make any sort of E decision here. It's whatever that one is, which is 1, because this one doesn't feed into it. 1 plus 4 is 5. And now I have to make an E decision. This one is 5. This one is 6. I choose the bigger. 6 plus 1 is 7. I go down to this one, and there's no E decision here, so I just put in 7 plus 5 is 12. This one I have to make no E decision, so it's 7 plus 4 is 11. And I have 12 coming into here. Now this one would actually have been better if I would have moved that over here a little bit more. I would have moved that node over here. It would have been easier to follow. Just a little explanation of why that the placement's important. I have 12 coming into this one. I have 11 coming into this one. I choose the bigger. 12 and 2 is 14. How long does it take me to do this? It takes me 14 days. That number right there. That's how long it takes me to do the process, to get some parts out the door from when I start, assuming I start them both at the same time. All right, so now it's time to back it up. So I'm going to do 14. And I'm going to do 12 because that's just what we do. And I have no L decision here, so I'm just going to put that 12 over here. 12 minus 5 is 7. And the nice thing is as we go, we can put a little dots because the top number and the bottom number are the same, so it helps us to identify where the critical path is happening. Remember, there can be more than one critical path. There could be 2, 3, 4, 5 critical paths. All right, I'm going to put that one there just for the heck of it. This one I have to make no L decision because I remember there's no 2 arrows feeding into it or backing into it. So I say 12 minus 4 is 8. By the way, notice this one's not in the critical path, but you don't have to think about that right now. You can just kind of crunch the numbers. I have to make an L decision here. I don't look at the top, look at the bottom when we're doing L's. I have 8 coming down from this one. I have 7 coming down from this one. Okay, remember smaller has 2 L's in it, so we choose a smaller one. So I'm going to say this 7 versus this 8. Okay, this 7 is smaller. 7 minus 1 is 6. And I come over here, no decision, so I do 6 minus 4 is 2. I go up this one, no decisions. I go 6. 6 minus 4 is 2. By the way, look at that. 6, 7, 6, 7. Oops, no, that's not right. 6, 6, 7. Sorry, 6, 7, 6, 7. Yes, on the critical path, which you kind of expect on this one. This one on the critical path because 2, 2, 6, 6, same numbers. Okay, I have to make a decision. I have 2 coming into 2 coming out of this one, and I have 2 coming out of this one, so there's really no decision. It's 2 minus 1 is 1. And you say, whoa, that should be 0. No, because you'll find out that this should not be on the critical path. So let's do this one. I have 2, no decision, so I put 2 and 0. And so you can see the critical path. It's A, I'm going to scoot this up here, A to C to E to G to H. And if you do this right, and again, what I just did is I recorded all these up here. on this thing, like you saw it. So I've done everything. So let's just see if we did this right. Our total time, if I add all these up, should come out to be 14. So that's a decent measure. So let's see. A, the time is 2. C, the time to do it is 4. E, the time to do it is 1. G, the time to do it is 5. H, the time to do it is 2. Let's see if this works out. 2, 4, 6, 2, 6, 7, 12, 14. That matches with this, so that's good. We're good. You do not have to do this. You do not have to do this part, but it does provide a little extra sense of sanity when you do it. So you do not have to do this part, but I recommend it. Unless, of course, I tell you prove it or something, but I don't think I usually have not done in the past. All right. I flip it over and we do the next one. I said, create a network diagram with all ESs, EFs, LS, and LF values. And I say deduct 1 point per. So you can lose a lot of points if you don't get this set up right, because it's not like, oh, I got that part right, I get 20 points. No, you have to, it's you start off with all the points and then you start deducting. So some people, there's been things in the past where students have gotten like -20 because they don't get 20, they get 0, but they actually lost more points even though they got a few things right. So, okay, let's go on with this one. When we're cruising down this one, we're looking for, to begin with, things without a predecessor. Nothing came before those. And remember what I said before also in chapter 14 is that sometimes don't write it in too darkly, because sometimes it's a little bit better to erase it and adjust it, because if your graph, the prettier your graph looks, the less confusing it looks, the more likely you're not going to make a mistake. So A and B have no predecessors. So I'm just going to put A and B. And I kept my line. I'm not going to put my times in. I'm going to do that at the end. It's just more hassle, more likely to be errors. So I've gotten that one taken care of. Now I'm looking for things that have A, B, or A and B. Well, guess what? Look at this one. C goes to A and B, and E goes to A and B. You say, well, how can that be? That doesn't make any sense. So what we do is we say, and I cannot remember, so I'm doing this off without looking at my notes because it's some, oops. So I put C and I put E. So I have C and I have E. I both have A, B. Good for me. All right. So what I do is I say, go. C goes to A, B. Well, guess what? We go there and we go there. And then we go E goes from A and B. Well, we go there. And this is a little bit of an engineering, electrical engineering little trick to keep yourself straight, because it's hard to get around there without making a mess. So if you get close to it, you swing it around and you just bring it down. So then it's easier to see that it jumps down there. Okay. So now we have this one taken care of. We have this one taken care of. So far, so good. So now we have A, B, C, E, but not D. Well, guess what? Here's C and E. C and E comes from D. Okay, so I'm just going to put this one here. I don't know exactly how much room I'm going to need, so I'm just going to kind of put it here. And it says D comes from C. I'll show you. C and E. Okay, I got that one taken care of. E, F. To do F, we're going to need G, which we don't have, but G comes from just only E. So I'm going to put G. I'm going to put, I like to kind of stagger them a little bit in case I have to go between them. G only comes from E. All right, got it. Now we have D. Oh, look at, see how smart that was not intentional, but it was. See how much I have space? F comes from D, E, and G. Because I spread those out a little bit when I did them, I just happened to, I didn't know that was going to be the case, but usually it's better not to make them go like this because then you can squeeze between them. So I know that F is D, E, and G. D, E, G is F. So I put F over here. And I go D, E, and G go to, and I remember make this F a little bit better. It looks like it, because I didn't have enough space underneath it. There we go. No need to, don't want to make any mistakes on, for those reasons. All right. So now we've got this done. The next thing, so we created the network diagram, but we haven't put the values in. So what I need to do is I just need to go down here and put the normal times. Remember the crash times, that's for later, okay? We're just gonna put in the normal times right here. So I'm just gonna go ABC is 2, 1, 3. A is 2, B is 1, C is 3. And I got 2, 1, 3. D and E, since I'm out to D, E is 3 and 2. D is 3, E is 2. F is 5. And G is 2. Now there's a tricky part, right? You could have switched those around because see, look at my, I go A, B, C, E, D is after E, F is before G, and all these. So, you know, don't think that it has to go A, B, C, D, E, F, G, like that type of thing. It doesn't have to go that way. It can go a whole different way altogether. So there's that. I'm going to go hide myself right now. Okay. All right. Okay, so we have to go calculate our ES's and EFs and LS's and LFs, and I'm going to put my question marks on it because it's a little bit more complicated. Remember, arrows coming in, I have to make my decision about E's here. No, yes, 2 arrows coming in, I have to make an E decision. I have to make an E decision. 2 arrows coming in. 2 arrows coming in, I have to make an E decision. 2 arrows coming in, I have to make an E decision. See, when you get into these decision things, oh, and don't forget this one, E, I have to make an E decision. So backing in, nothing backing in. Oh, yes, no, sorry, I forgot about the backing in. Arrows, 2 arrows coming in here, 2 arrows coming in here, 2 arrows coming in here, only 1 arrow coming in there, 3 arrows coming in there. So those are my E's. My L's are the ones where the arrows back into it. The tail ends go in. No, only 1 tail in here. Only 1 tail in here. There are 3 tails in here, so we have to make an L decision among those 3. We have, oh, that was a big mistake. Sorry about that, people. I got ahead of myself. I told you the wrong thing and I fixed it, luckily. This one, you have to make an L decision. This one you have to make the L decision because the arrows are backing in, only 1 coming in here, several backing in here, only 1 backing in, only 1 backing in. So it looks like we got everything pretty much covered. So now we just have to start crunching through the numbers. Start at 0, that's the earliest we can start. 0 plus 2 is 2, 0 plus 1 is 1. All right, we have the choice here. Remember, we take the bigger on the E's. We have the choice between 2 and 1. We're going to take the bigger, which is 2. 2 plus 3 is 5. We go down here. Guess what? We have 1 here and we have 2 here. It's going to be the same thing. We're going to choose the 1 here and 2 here. We're going to do 2 plus 2 is 4. We cruise over here. We have to make decisions on this one. Which one's bigger? We're going to go with the bigger, which is the 5. 5 plus 3 is 8. We might as well go down to this one. This one is supposed to be 4. No decisions on E, so we're just going to go 4 plus 2 is 6. All right, so now we have 3 choices. We have 8, we have 4, which obviously we have 8, we have 4, and we have 6. We choose the biggest, 8. 8 and 5 is 13. By the way, remember that's how, I shouldn't circle it, I should underline it. That's how long it takes us to process our material to finish units. Okay, 13. Don't put that circle around it. I want you to think it's a node. All right. as we did before, we put 13. 13 minus 5 is 8. Obviously, this is a critical path. Why? Because every path that you could possibly plan for goes through this point. So you know that's in the critical path because it has to be. All right, so I have to go back here. I have 8, no L decision here, so I'm going to go 8 minus 2 is 6. Got it. I go back here. Oh, I got some L decisions, so I got to wait. No, I have 8 minus 3 is 5. And so I cruise back to this one, and I have, remember, L's, we're going to choose the smallest. I have 5 here, an LS of 5, a late start of 6 here, a late start of 8 here. So my smallest LS is going to be the 5. Okay. 5 minus 2 is 3. By the way, not on our critical path. The numbers don't match. Not on our critical path, assuming we did it right, which there's always, this one does match. 5, 5, 8, 8, so we know that's on the critical path. Okay. This one, there's no decision, no L decision, so we just say 5 minus 3 is 2. Oh, these line up nicely. We know this is on the critical path. Remember, there can be more than one critical path, but we'll see if we have this one done. So our choice is we have 3 back going into this one, and we have 2 going into this one. So we choose the smaller, which is 2. 2 minus 1 is 1, not in the critical path. This one's going to be the same. We have 3 coming into here. We have 2 coming into here, so we do 2. 2 minus 2 is 0. And our critical path is equal to, is A to C to D to F. If we did that right, we should come out to be 13. So what's A? A is 2, plus C is 5, plus 3 is 8, plus 5 is 13. So that sounds right. Okay, so let's see if we did this. We create a network diagram with all the values. Yes. We identify the critical path. Just did that now. Identify least expensive way to shave off 2 hours. Now, that means that this time is in hours, not days. Okay, least critical time to, least expensive way to shave off 2 hours. So this is where it gets to be a little bit trickier. And what we have to do is, remember, the only thing that matters when we're looking at this stuff is stuff that's on the critical path. So we are only worried about A, C, D, F. So what I'm going to do is, so I don't mess myself up, I'm just going to cross, whoops, I want to keep the A, sorry. We want to keep A, we're going to get rid of B, C, we keep, D, we keep, and E we get rid of, F we keep, yeah, okay. So we have A, C, D, A, C, D, F, and I crossed out everything that A, C, D, F. Those are the only thing that kept, okay. So if you have room here, you could do this, but since we don't have room, I'm going to make myself a little table. I'm going to go A, C, D, F. These are the things we're going to crash. So I say change in time, change in money, change in money divided by change in time. Okay, those are our 3 categories for those things. And I'm just going to put a line here so it's easier for us to follow it. So I say, what's for A? My change in time is 1. 2 minus 1 is 1. I go down to C. See, look, I don't want to do that. That would trick me. Go from 3 hours to 2 hours. The change in time is 1. Okay. I go down here to the next one, D. Change in time is 1. And change in time is 1. I have to, so this tells me right away, that's, I can save an hour, and that's the most I can save on any of these operations, which tells me that I'm going to need to pull them to save 2 hours. I'm going to have to pull them from 2 things, because no matter what I pick, I'm only going to be able to shave off 1 hour if I choose just one, because that's all there is available. It's like you've used it up, and now you have to go find other sources. Change in money for A is $20 more. I guess I put 20 down. For C, I should cross C's out too, but I did. C, that's $35. D, $30. And F, $25. Okay. Now, if we're really supposed to take this number and divide it by that number, this number divided by that number, which in this case, it's just going to be so we say, all right, find the least expensive way to shave off 2 hours. Well, what's the cheapest way to shave off an hour? Is this one, which is $20. So what I'm going to do, I'm going to choose A at $20. Okay, choose A at $20, and that's my first hour. To shave off 2 hours, I have to pick something else. So I say, well, that one, this is the next cheapest one. So I'm also choose, I'm kind of stuck in the middle of a crack. Choose F at $25. Okay, that's $25 more, okay, than it would cost me normally $25 to get it done faster. Actually, $20 plus 25 would be $40, $45 more. But here's the question. Identify the least expensive way to shave off 2 hours. You're going to choose A and F because of these reasons, okay? So we got that taken care of. That's that answer. Then it says, identify the additional cost. If I would have said total cost, if I would have said, how much is it going to cost me now totally, you would have to add up all of your normal costs, all these numbers up, and then add in the $45. But since I did not say that, I said identify the additional cost to shave off 2 hours. All I'm going to say is the additional cost, and I keep getting in this crack. Additional cost is equal to $45, and that would be the answer to that part. Okay, that would be the answer to that part. This right here would be the answer to this part right there. And critical path, that would be here. Down there, there'd be the critical path, and CP critical path. All right. Stop share. So hopefully, there's another example. Well, actually, 2 examples, but for this particular segment. So hopefully you did okay when you worked out your practice problem. Again, please do those first. If you're reading it, listen to it now. It's probably a little bit too late, but hopefully you listened to it at the beginning. All right, end of this segment.